Welcome back, everyone. We're excited to have you with us as we dive deeper into what powers our AI systems, inspired by the book Fourth Industrial Revolution and 100 Years of AI by Dr. Alok Aggarwal. In our last episode, we uncovered the fascinating world of MLOps, the practices that keep AI systems running smoothly in an ever-changing environment.
And we left off with a teaser, the three pillars of MLOps: DataOps, ModelOps, and MLDevOps. Today we're diving deeper, starting with DataOps, the foundation of any successful AI project. Ever wonder what's really going on behind the scenes of all those crazy AI systems everyone's talking about?
Yeah, it's fascinating, right?
Totally. So today we're diving deep into the world of data engineering pipelines, the real workhorses behind AI's success.
Most people don't realize how much work goes into preparing the data before an AI can even touch it.
A recent study mentioned in the book found that 75% of the time spent building an AI system is devoted to preparing the data. So today we're going to break down the 5 key stages of this process to understand just why data engineering is so crucial. So we have to start with the basics. Data ingestion and gathering the raw material for our AI seems pretty straightforward.
Absolutely. But you can't just to grab data from any website. You have to consider things like copyright, especially when dealing with, news articles, for example.
So you're saying there's a whole legal layer to this before you even start analyzing the data itself.
100%. And this need to be super careful as it continues in the next stage. That is, data exploration.
Okay, what is data exploration all about?
It's kind of like when you meet someone for the first time. You're trying to understand them. You know their personality, their strengths, their weaknesses. But here, instead of a person, it's a massive data set. You're analyzing its structure, its format, and whether it's even suitable for what you want to do with your AI. And this understanding depends on something called metadata, right? It's basically data about the data. Think of it as a label that tells you things like when and where the data was collected, what format it's in, and how reliable it might be. This metadata is essential for organizing the data and using it correctly.
So this sets the stage for how well the AI performs when you tailor the data to fit the specific task you're trying to do with the AI.
Exactly. And once we have a good grasp of our data, it's time to roll up our sleeves and get to cleaning.
What do you mean by data cleansing?
That's where we tackle inconsistencies, errors, missing information, or anything that could mess up the AI later on.
It sounds kind of tedious, but I can see why that'd be really important for, making the AI accurate.
Think of it like building a house. You wouldn't build a house on a shaky foundation, right? Data cleansing is about making sure the data we feed the AI is solid. It involves things like standardizing formats, correcting errors, handling missing values, even removing unnecessary information.
That makes sense. And it's not just about cleaning up errors, it's about making the data fit the purpose of the AI.
Exactly. And now we come to the most labor-intensive stage, data labeling. This is where humans often step in to manually categorize the data, giving the AI the context it needs to learn. But it's not as easy as just putting on simple labels. Imagine we're training an AI to, let's say, identify different types of flower images. 2 people might label the same flower differently.
Yeah.
One might focus on, the petal shape, the other on the color, and those little differences can affect how the AI learns.
Wow, I never thought about how much human judgment goes into data labeling.
It's super important and often requires expertise in a particular field. We need people who really understand scientific language to label accurately, and clear communication is super important.
Right? Okay, so we've gathered the data, explored it, cleaned it up, and labeled it. What's next? What's the final step before we let the AI work?
So the final stage, the grand finale, is data splitting. We carefully divide the data into separate sets, one for training the AI and another for testing it. This makes sure that we're not just teaching the AI to memorize the data, but to generalize and make good predictions on new data stuff it hasn't encountered before.
Okay, I think I'm starting to understand this whole pipeline now. Now let's explore how to keep those complex systems running smoothly and accurately.
AI models are not set-it-and-forget-it systems.
So how do we make sure our AI stays in tip-top shape?
Well, that's where we get into this concept of ModelOps. It's think of it as a series of checkups and adjustments you would do to keep a system running.
Okay, so kind of like taking your AI to the mechanic. So walk us through this ModelOps process. What's the first step we need to take?
So the first step is, well, we call it feature engineering. So imagine you're baking a cake. The ingredients you choose and how good those ingredients are going to determine how delicious your cake turns out.
Makes sense. Garbage in, garbage out.
Right? And that's kind of what feature engineering is all about. Picking the right ingredients, the right data to feed to our AI model.
Okay, so those are like our flour and sugar, the basic building blocks.
Exactly. But to make a really tasty cake, you need more than just flour and sugar. You need those spices, the little extras that add complexity.
The secret ingredient. So it's not just about giving the AI a ton of data. It's about selecting the right data, the stuff that will help it learn.
Absolutely. That's what's going to make our cake delicious.
I like that. So okay, we've carefully picked our ingredients and fed them to our AI. What's the next step in this ModelOps journey?
Okay, so now it's time for step 2. And this is where we get into model training and hyperparameter tuning. Think of it like coaching an athlete. We have our athletes in our AI model, and we want to train them to be the best.
They go for the gold.
Yeah, exactly. So we pick the right training drills or algorithms, and then we got to adjust the intensity, how hard we're pushing them. And that's where these hyperparameters come in.
So hyperparameters are like the dials and knobs we can tweak to fine-tune the training process.
Yeah, exactly. We can adjust the learning rate, which is kind of like how quickly our AI learns from the data it's seeing.
So it's like deciding how much weight an athlete should lift or how many laps they should run. Too much too soon. They might get injured.
Precisely. We don't want to overload our AI. And then there's something called epochs, which is how many times the AI goes through the entire training dataset. And the more epochs we run, the more chances our AI has to learn and get better at summarizing those articles.
So we've got the right data. We've trained our AI like an athlete. Now it's time to put it to the test, right?
You got it. Step 3 is all about model validation and testing.
Because we wouldn't send an athlete to the Olympics without any practice, right?
Exactly. We need to know our AI can perform under pressure. And this is where that small set of data we should set aside comes in. Those are our test sets.
Ah, right, the final exam.
Exactly. Yeah, it's like a real-world simulation.
Okay, so how does all this testing apply to, to the real world? Why should I care if I'm not like an AI scientist?
Well, think about it this way. Would you trust a medical diagnosis from an AI that's never been tested, or get in a self-driving car that hasn't been through tons of simulations?
Oh, no way, that's a little scary.
Right? Testing is what gives us confidence that the AI systems we're using are accurate and safe.
That makes sense. So our AI has passed its exams. What's next in this ModelOps pipeline?
Okay, so step 4 is all about packaging things up. We call it model packaging and versioning. You know how when a new video game comes out,
Oh yeah,
it's all packaged up nicely,
I love that new game smell.
right? Well, it's the same idea with AI models. Once it's been trained and tested, we gotta package it up so other people can use it.
So it's kind of like creating a blueprint of our AI so anyone can build their version.
Yeah, that's a good way to put it. And just like software, we need to keep track of different versions as we make improvements.
So we know which version we're using, and we can go back to an older version if we need to.
Exactly. And in a business, this is super important. Imagine deploying a buggy or outdated AI model. It could be a disaster.
Oh, yeah, so we've packaged our AI like a shiny new game. What happens next?
Okay, this is where things get a little more technical, but stick with me. Step 5 is model serving and predicting. You see, traditional software is pretty static, but AI needs to be flexible. Think of a restaurant kitchen. During the dinner rush, they need more cooks, right? But when it's slow, they can scale back.
Gotcha. So our AI needs to be able to adapt to changing demands.
Exactly. And this is how AI powers so many things we use every day. Think about self-driving cars, analyzing traffic, or, getting personalized recommendations on your phone. They're essential for making AI work in the real world.
This is fascinating. But with all this complexity, how do we make sure AI stays accurate and doesn't, go rogue or something? What's the last step in this whole process?
The last and most important step is model performance monitoring and logging. It's all about keeping a close eye on our AI and making sure it's staying on track.
So it's like having a coach or a personal trainer for our AI, making sure it doesn't slack off.
Exactly. COVID AI is a perfect example.
So if that AI was trained on data from 2020, it might not be so good at understanding articles about COVID today.
Right? That's called concept drift. the meaning of things changing over time. The virus has evolved. There's new information about vaccines and treatments, and long COVID and all sorts of things. That's why we need to constantly track how our AI is doing and retrain it when necessary. It's an ongoing process, just like anything else we value and rely on.
You're right. Those are all key pieces. It's almost like a chain, you know? DataOps ensure that the right data is flowing in. MLOps focuses on building and refining models. MLDevOps connects all that with the world of software development. So we're bringing those rapid-fire updates, constant testing, and deployment cycles from software development into the AI world. But AI models aren't static like apps. They're constantly learning. So how do we manage that?
Yeah, that's where things get interesting. We talk about continuous integration, deployment, and monitoring. But now apply that to an AI model that is constantly evolving and learning. It's a huge challenge. Imagine you're trying to update a system while it's learning. You're validating those updates in real time, all while making sure the whole thing is secure.
It sounds like a constant juggling act, and the dynamic adaptation of the infrastructure, which sounds a lot different from traditional software. Can you unpack that a bit here?
Absolutely. AI is incredibly resource-intensive. We're talking massive amounts of data and complex computations. It's not like traditional software that runs on a server and you kind of know what to expect. AI infrastructure has to be able to scale up and down on the fly depending on what's happening.
So if an AI system is suddenly hit with a huge influx of data, the infrastructure needs to be able to just handle that without breaking a sweat and then scale back down when things are quieter.
Exactly. It's about optimizing resources and making sure that the system can adapt to unpredictable demands. And to make things even more complex, we're moving away from the traditional CPUs and GPUs that most people are familiar with.
Oh, right. And what kind of impact do AI chips have? I've heard it somewhere but don't know what they do.
Well, these chips are designed specifically for the types of computations that AI models need. They can be much faster and more efficient than general-purpose hardware, but they also create new challenges in terms of infrastructure design and management. It's a constantly evolving landscape.
Okay, what's the importance of real-world context? Even the most advanced AI models sometimes struggle with that, right?
Yeah, that's such a crucial point. An AI might be great at recognizing patterns, but it doesn't understand the world the same way humans do. Here's a great example. Imagine an autonomous car stopping for a stop sign, but the sign is in a second-story window of a building.
Okay, that's hilarious, but also kind of scary if you think about it. So how do we teach AI to better understand those nuances of the real world?
That's where ModelOps comes in. It's the process of constantly updating and refining an AI's knowledge base, taking into account new information, changing language, and even major world events.
So like teaching the AI that it doesn't always mean what the dictionary says it means.
Exactly. Language changes, new concepts emerge, and the world throws us curveballs. ModelOps is about making sure those AI systems can adapt and stay relevant. And remember, any major update to the knowledge base can have ripple effects across the entire AI system, potentially even triggering a whole new MLOps cycle. It's all connected.
Wow, it shows how complex managing these systems can be.
And AIOps is an umbrella term for all this. It encompasses MLOps, knowledge ops, and a crucial piece we haven't gotten to yet, governance ops. Think of it like the control panel for making sure everything runs smoothly and responsibly. It's a crucial element of the whole AI ecosystem. It's not just about building these systems and maintaining them. We also have to make sure that they're being used responsibly and ethically.
It's easy to get caught up in all the technical marvels of AI, but we can't forget about the human impact. The book breaks down governance ops into these 5 key areas. Why is it so important to understand how these systems reach their conclusions?
We need to be able to understand how the AI reached its decision. We can't just blindly accept the output. It's about transparency and accountability, making sure that AI is a tool that we can trust and understand. And it's not always easy. As these AI systems get more complex, it can be harder and harder to trace those steps. Like, how did it actually get to that conclusion?
Sometimes you might want to use a simpler model, even if it's a bit less accurate, because it allows for more interpretability. Is that a common trade-off that has to be made?
It is a trade-off, and it's one that we really need to think about carefully. It depends on the specific situation. Sometimes accuracy is the most important thing, and other times that interpretability might be more crucial.
It makes me think about the evolution of AI technology in general. As these systems become more and more sophisticated, the challenge of ensuring interpretability is only going to grow, right?
It is a challenge, but it's one we have to face head-on. We can't just treat AI as this black box. We need to develop tools and techniques so that we can understand that reasoning process and make sure that these systems are aligned with our values.
It's clear that this journey with AI is just beginning, and there are going to be amazing opportunities and challenges along the way.
Yeah. Now we're going to explore a few more cutting-edge techniques that are pushing the boundaries of AI. Imagine training AI models without needing mountains of data, or keeping your information private, but still benefiting from collaborative learning.
So that's what we're unpacking now. The how, the why.
We'll talk about the 4 key areas: active learning, transfer learning, federated learning, and meta learning.
Oh, I'm ready to have my mind blown. Let's kick things off with active learning.
Okay, so active learning tackles a massive challenge in AI, that is labeling data. Training an AI model usually involves labeling tons and tons of data, which can be super expensive and time-consuming, like way more than anyone wants to deal with.
It's like trying to read every single book in the library just to find one specific fact. There has to be a better way, and active learning is the smarter way.
So instead of just blindly labeling every single thing, it picks out the data points that are the most valuable for the AI. Like imagine diagnosing rare diseases way earlier, or developing those life-saving drugs faster. All because active learning helped train a model on not a ton of data.
But how does it work? Walk me through it.
Okay, so let's say we're training an AI to tell the difference between cats and dogs.
Okay, classic example.
We've got 1 million images. Instead of labeling every single one, you start with maybe a smaller set, like 10,000, to train like an initial model. It tries to predict the rest of the images.
Oh, so it just starts guessing about the other 990,000 images?
Yeah, but here's where it gets really interesting. It uses that first round of training to predict the rest and then focus on the ones it gets wrong. Especially the ones where it was super confident but wrong, because they highlight where the AI is struggling.
So it's like the model is saying, wait, I thought I knew what a dog looked like. I need more information.
Yes, and by zeroing in on the most informative images, active learning lets the AI reach high accuracy without needing to label everything.
Wow.
This saves so much time and makes AI development way faster.
Okay, ready to move on to the next big thing?
Yeah, let's talk about transfer learning. All right, it's all about using existing knowledge for new tasks. So let's say an AI has been trained to recognize cats.
So we could use that cat knowledge as a starting point to teach about tigers, instead of starting from scratch. But I am curious, does this work for any task, or are there limitations?
Yeah, that's a great question. It works best when there's a lot of overlap in the features between the two tasks. Probably won't help that much when it comes to identifying different types of cars.
Right? Totally different features?
Yeah, the skills just don't transfer. And that's why researchers are developing models that are specifically designed for transfer learning.
Oh, cool. Imagine speeding up AI development just by building on prior knowledge.
But how do we do it without compromising privacy in real-world cases?
Okay, yeah, that's a huge concern. We don't want our personal information just floating around in some giant AI brain in the cloud.
Exactly. That's where federated learning comes in. It lets us train AI models on data that's spread across tons of devices without even sharing that raw data.
Okay, that sounds almost impossible. How do you teach an AI something without giving it the information to learn from?
It's like magic. Imagine your phone, along with billions of others, is secretly helping to train this global AI, all while keeping your data private. That's the magic of federated learning. It starts with a central server sending out a basic model to all these devices.
So each device gets its little AI apprentice.
Yep, exactly. Then each device trains the model on its own local data.
So each model is kind of getting customized, but the data never actually leaves the device.
That's the key. So once the devices have trained the model, they only send back updates on how the model's parameters have changed. So it's like not the actual data.
It's like sending instructions for improvement, but not the actual ingredients. So all these little AI apprentices are sending back their notes on what they've learned. And then what happens?
The central server gathers all those updates and combines them to create a new, globally improved model, which is then sent back out to the devices.
Oh, wow. So it's a never-ending cycle. So we're talking about a global AI brain.
Global AI brain. That's learning from all these different experiences all over the world.
But without anyone having to compromise their privacy. That is pretty mind-blowing. But I imagine there are some challenges with this approach.
Yeah, there are definitely challenges. One challenge is making sure the local datasets aren't biased. Like, for example, if all the data is on one device came from a single demographic, right? It could skew the global model. Another challenge is that the datasets on different devices might be totally different sizes. Some might have tons of data.
We need to find ways to make sure everything's balanced.
Okay, so federated learning has some serious potential, but we still need to iron out some wrinkles.
Okay, now let's step into the realm of meta-learning, AI that can learn how we'll learn.
All right, we've gone from efficient learning to knowledge sharing. And now we're talking about AI that can essentially teach itself.
That's right.
It moves beyond training AI for just one specific task. It's about equipping AI right with the ability to learn new things more efficiently and adapt to new situations.
So instead of being a specialist, it's becoming more of a generalist?
It's like the difference between memorizing specific facts and learning how to think critically. Meta-learning focuses on the latter.
Yeah, how does it do that?
One way is by optimizing something called inductive bias. So think of it like having a toolbox. The tools in your toolbox influence how you approach a problem. So inductive bias is assumptions about the world. And meta-learning helps the AI choose the right tools for the job, so it can learn more effectively.
So it's like the AI is learning how to learn by figuring out which mental tools to use. That's pretty amazing. But before we go too far down the rabbit hole, are there any challenges with meta-learning?
One challenge is overcoming the brittleness of current AI. Although meta-learning seems to be quite powerful, at least in theory, it seems quite hard to achieve because of the brittle nature of complex AI systems that function poorly with a small amount of additional noise. Like, even small changes can cause these big drops in performance.
And as the changes continue, we can expect even more innovations and applications in the evolution of AI with various challenges.
All this also highlights the importance of not just developing these technologies, but also considering the ethical and societal implications.
Oh, for sure. We need to make sure we're using these advancements to benefit humanity, not just to automate it out of existence.
The future of AI is full of possibilities, and it's up to all of us to shape it in a responsible and beneficial way.
Absolutely.
Well said. Thank you so much for joining us in this incredible deep dive into the world of AI advancements and understanding the three key pillars of MLOps, DataOps, ModelOps, and MLDevOps that keep the AI systems running smoothly. In the next podcast, we'll learn about the future of computing and its various theories written in the book The Fourth Industrial Revolution and 100 Years of AI. Goodbye until next time. Keep those brains buzzing.